Hello everybody. I decided to do another programming video, an update on my program. Um, I've been doing a lot of work to it. You can see that I've got 5 errors. It doesn't work. Like if I try to run this, let's see what happens. It's gonna be bad. It's gonna be so bad. Maybe it'll work. No, it ain't gonna work. There's no way. I've got so many problems right now with it. And this is the problem. Oh, yep. There were build errors. No, I don't want to do that. 280 errors. Yeah, there's a lot of problems going on here. Um, and there's a lot of redefinitions apparently. So anyway, this is just a short little update video. I've been working, doing my thing, and I just it's really coming together, and that's what this video is going to be kind of like an introduction to what I've been up to, because now I can kind of show you more. Um, you'll notice here I've got 2 window panes. I've got this little window here and then this little window here. Okay, so this is another file that I'm going through. These are the 2 files I'm working with, which is O1 core ML enumerations.header and O2. You can't really read that, but that is transition baseline support.header. Okay, so let me pull this out and show you the project total, the whole thing. So this is the solution explorer. This is the entire project at a glance, so you can kind of see all the files. So this file and this file, so the files that you see here are these very 2 first files here, right? And there's a lot more. There's a lot more. Some are included in the project, some are not. But let's focus on these first 2 files, shall we? I just want to show you what I've built and what has been created so far. So let's start with O1 enumerations, right? These are like just states that can be determined. For example, this very first one is called error severity. It has 10 enumerations in it from custom to unknown. And basically what this would allow my program to do is if your program encounters an error, right, it crashes or something, well, my program, when it's finished, is going to be able to use this enumeration to let the system know, hey, there's an error, it's critical, or it's fatal, or it's just a warning, or it's just a notice, or it's just an informational, and that's just one of like 26 of these that I have so far. So that's this file, and it's got a bunch of controls you can compare it to. You can make sure it's valid, that kind of stuff, which is, I worked really hard on that stuff. I'm pretty proud of that. There's alert level. That is slightly different. That's trace debug. It allows, that's for a different aspect, and I'll show you that to you here in a minute. So all of these do a different thing. And let's go ahead and show you that part. So that's O2 transitions baseline support. So in that particular file, or wait, no. I have to go to a whole nother. Hold on. See, this is where I get lost in my own project because I've got so much crap going on, and I gotta find something. Hold on. Is it in the chain or the snapshot? No, it's not in the snapshot. It's in the chain. And I'll explain all this in a minute. Temporal. Oh, wait. Oh, my God. I've made so many changes to this program. I don't know where anything is. Is it an additional baseline? Oh, yes, it is. Maybe it is. No, it is not. Core transitions? No. State snapshot? No. I'm gonna have to take a pause and find it. Sorry for that interruption. I found it. So there's just so much. There's just too much. So that alert level would be used in something like wherever you are. Hold on. See, this is how I get lost. I just get lost in the code. Yeah, I got a timestamp class, and I'll explain that in a minute. I'm trying to get to We're getting there. So like, you'll notice here, there's alert category. That's going to have to get moved over here because for whatever reason, AI decided to just throw a bunch of structs together like this. Like, look at this. Struct alert, enum class alert category, struct alert action, struct escalation rule. All of this stuff should be separate. All of it. And that's what I'm working on right now, is separating out and kind of using things where they need to be used. So anyway, let's start from the beginning because that doesn't really help. All right, so like I said, I have this O1 core ML enumerations.header, and that's just states, right? Now, if we go to O2 transition baseline support, that's where things get more interesting, right? So the enumerations aren't that interesting. It's literally just like trace, debug. It doesn't really do anything. What I'm about to show you is where the difference is. So let's start here with this very first struct on line 16. And let's open it. And we'll look at it. In section 0 states shared state defaults. And that's because this struct is going to be used everywhere in the program. So what I've done is I've taken all of these structs in this file over here, the alert level, all the way down. Now I'm not all the way done because I just added recent, like all of these. TS aggregation, trend reliability, trigger mode, you know, and I could spend hours telling you all about all of this, and I don't want to get into all the details. I'm just wanting to show you what I've built so far. And I'm quite excited about it because while it has 422 errors and it doesn't work, it's coming together quite nicely. And it only has errors because I've made significant changes to the structure of this program where it's expecting certain things that isn't there anymore because I'm renaming files, or I'm restructuring things. Like this all used to have just core ML baseline. It now has an O3 in front of it, the folder, right? This has O2 control blocks. This is O1, a graphical system. I'm not going to, I'll go into that in a separate video. This allows me to like develop graphical programs. Anyway, back to the program. So like I said, I've got this shared states configuration that, as you can see, has error severity, alert level, alert status, alert priority, access level. These, now, like I said, this isn't a complete list because there's trend reliability and there's TS aggregation, as we can see here, shared state this. But as you'll notice, I've made a few changes. Anomaly type, exception level, exception safety guarantee, ownership type, strategy type, trend. And then these are just kind of like, they throw errors, right? I got to test it yet. But anyway, and by the way, from the first video that I've done on this video, or on this program, the very first file, if anyone remembers it, it had 21,000 lines of code in it. It's now 25,000 lines of code. So everything just keeps growing. Anyway, so like I said, it doesn't, this shared states configuration struct, which is just a like class, does not have exception level, anomaly type, or any of this stuff in it yet. And I triggered that yet because it's going to be added. And like I said, this particular struct is going to be used everywhere. Same with this one. This is kind of like a another way of like enabling and disabling features in the program using booleans. Still working through all of that. So there's that struct, and then there's the feature vector metadata, which actually that is duplicated. I thought I saw that somewhere else. Let's look at that. That's just kind of like additional information. It's kind of like a vector, stores data. And then we've got conversion quality report. This is where it gets more interesting, right? So instead of it just being none basic strong, no throw unknown, now we have Boolean values and double values, which double is, in programming, double means something with floating point in precision. So like 0.0 or 3.14, which would be pi. that's when you would use a double. If you wanted to use an integer, which is int, so let me demonstrate that. So let's go down here. I'm going to delete it. I'm not going to keep it. The difference between a double and an integer, test int equals 1. Oh, okay. All right, what are you doing now? See, this is what it's been giving me grief all day. Oh, okay. It's been giving me grief all day. So anyways, like I said, a double is a floating point. So like double pi equals. Thank you, AI. I know what pi is, though. Might as well. All right. So like I said, a double will allow you to store a number like this. An integer has to be like this. You can't do int double int. Oh no, I couldn't even do that if I wanted to. Equals 2.0. Yeah. See, it won't let me do that. I promise you. I promise you, it won't let me do that. So, like I said, what's interesting about structs is they are an aggregate. That's what a struct is, and you'll notice that in the name, struct conversion quality report. And a struct and a class are the same thing. They're user-defined objects, is what they're called. So let me go ahead and delete all this extra crap because it doesn't belong there. Okay, that's the conversion quality report. And it's not just these little variables, right? Or these vectors of errors and warnings and info messages, right? It's also functions, right? It's also constructors. It's also, I mean, you can add an error, you can add info, you can finalize, you can calculate quality score, and it goes on and on and on. I'm going to go ahead and close that one because these are all basically the same. And that's just a couple in the very top. We've got access statistics. You know what? Actually, let's go through them all. I was going to skip around, but no, let's not do that. Okay, data quality score is the next one. So we'll look at that. That's got a couple doubles, and that's really all this is. And it's pretty self-explanatory. The comments are self-explanatory as to what each thing means. I'll keep that up so you can take a look at that for a minute. And like I said, each struct has these little accessors, and that's so that you can use it. Okay. That's the data quality score. And we got a report, which is basically just more additional information. That's a much smaller one. I haven't really built that one up yet. Memory allocation record. So why I'm not really saying anything is I'm just kind of letting you see what I've put together so far for this. It's called AI Healer. Okay, and now I realize we've all seen Terminator, and I know that AI is the bane of our existence in many ways, but it's also very helpful. And I'm building something that is AI-ish, but it's not what you think. It's only going to do one thing, and it's not going to be self-aware. It never will be. And it will be to a certain degree because it has to be able to resolve problems. But I'm just going to have to be sure to put safeguards in. That's all. Like I said, we got memory allocation record, a bunch of functions. Resource ownership, which is ownership type. which if you look over here, has unique, shared, weak, borrowed, and moved. So that's the very first item in resource ownership. And then we've set it to unique. We've got some size t, which is kind of like another way of using integer, but it's more confined, more useful in that way. One thing we haven't talked about is a bool, right? Bool. Bool is Boolean. It's true or false. So like that one in particular, is this resource ownership valid? True or false? And you can set that to true or false. And if it's false, then the system will act accordingly. And same with true. Let's see. And then we got access. Now we got statistics for state changes. Ooh, this is exciting. So we got confidence score. Ooh, wow, that's got a lot of stuff in it. A lot more. We got mix. And this is what's beautiful about programming is that you get this is what I get to do. I enjoy doing this because it allows me to expand my brain. Really, it's kind of like playing chess, right? Because you gotta. It's like putting pieces together to solve a puzzle. You want something to do something, and a computer's inherently stupid, right? That's why I've got all these different structs because I want to make sure it's going to do what I want it to do, and so it's beautiful in a way, but it's mind numbing at times because as you'll see, we're only at 2,000 lines. This is about a 15,000 line file. So like I said, this one, it's just like a confidence score for the whole program. How is it doing? There's tracking, evidence and support, confidence bounds, confidence calculation components. That's the confidence score. But you also have, so if you've got two confidence scores, right? You can see if they're equal. You can see if they're not equal. You can see if one's less than or greater than, or, and then you got these query methods to see is high, is medium, is low, is sufficient, get confidence level, which will return just this text onto the screen for now until I change it. That's confidence score. Let's look at code quality metrics next. Again, a bunch of like Boolean size t's, doubles. And these are just, more metrics to be able to see what's going on in the program. And this one's quite long. There's quite a bit. There's historical. Let's go through this. And this is obviously, the section 4 is wrong. There's the core quality metrics, which is cyclomatic complexity, cognitive complexity. Now remember, this is an AI model. That's why it's cognitive complexity, cyclomatic complexity. That's what I mean by AI. I don't mean like I'm going to build a robot. That's what I'm not building here. That's absolutely not what I'm building here. What I am building here, though, is a program. It's kind of like a statistics program. That's really all I'm building. But what I'm going to try to do is, at first, it's going to be statistics. But eventually, I'm going to try to make it not self-aware, but self-aware enough that it can prevent a program from completely crashing, but not become self-aware to where it can heal itself. I don't want that, because then we will have a Terminator. And eek, big time eek. So like I said, we got code quality metrics, which has, code structure metrics, dependency metrics, on and on and on. Conversion metrics, performance tracking, data quality tracking. It just goes on. And I feel like I'm just going to skip all the code quality and get on to the anomaly threshold. So these are all just different types of statistics. You got latency, recurrence, recovery. It goes on. So let's look at conversion. Or did we look? Yeah, we looked at conversion. Let's look at execution metrics next. That has the basic metrics, the history, the thresholds, the tracking flags, the constructors, and that's it for now on that particular struct. Because right now, I'm just trying to get it organized. I'm just trying to get it to where it's like, okay, everything's where it needs to be. Let's start building it, right? Because it's a big giant mess at this point. I've got structs where they don't belong. I've got just everything. This is a mess. As you can see, it's just a giant mess. Yeah, and like latency statistics, sample tracking, SLA tracking, latency distribution, tracking timestamps, thresholds, monitoring flags, constructors, and then there's that struct. And then there's reoccurrence metrics. And these are just statistical data. The core data. And this one's actually kind of small. Well, I say that and then I keep scrolling. Like I said, you can check whether it's equal or not. Three-way comparison, record occurrence, calculate intervals. And and this is all yeah, this is a big one. Still in that same one. Oh, there we go. And see, like, hold on, let me get up to the top. That's recurrence metrics. Then we've got recovery. And that's got, your core recovery data, the extended data, default constructor, bunch of constructors. And then, your comparisons. And then a bunch of functions that can be used for this particular struct. And as it's coming together, it's a beast. Memory stats. This is a much smaller one, thank God. You can see it all in one little pane, you don't have to scroll. So, and it keeps growing, like this is after because what I've done basically is I've reorganized it, because this was in a specific order and now I've rechanged it to this particular order. And then we got memory pressure info. And then we got a statistics hub. And this hub is going to be kind of like where all of that statistical data up above, right? So like statistics, this one, statistics, mean, median, standard deviation, min, max, variance, range, sum of squares, performance class, quality class. And this is a much more unique. And what's unique about programming is now, if I wanted to, now I've got statistics. If I wanted a statistics hub, right? I already have it. So we got individual access. Well, then I can be like, well, we need we'll do something like that. And so now what I've done now is I've just created a member here of this. So if I wanted to, I could, let's go ahead and we'll pick this mean, right? So what I could do is in the statistics hub, I could write a function, void, we'll call it void update mean. No, why are you doing that to me? It does this to me all the time. It's very maddening. Update mean. And literally, we'll just create a double. Mean equals 0.0. Okay, and then we can just do overall statistics dot mean equals, oh no, you know what? Actually, this is going to be a problem. I can already see that being a problem. We'll just do testing mean. And we just have to do that. And so what this would do, this would then allow you to update this particular member of this struct, right? So that's the kind of stuff we get to do as programmers. It's kind of fun. It's kind of cool. And that's just a little baby example, right? I mean, I did that for you just to show you that I can do it without the help of AI. And number two, I only use AI because I don't want to sit here and type all this out. You know how long it would take me to manually type all of this out? I don't want to be gray. I don't want to be a 90-year-old man. I'd like to get this done in the next decade because I don't have any idea how long this is going to take me. Like, let's continue looking at it. Like anomaly threshold, which is another thing that I'm kind of building. We're going to go ahead and remove this. Actually, no, I'm not going to remove that. I'm going to remove this because I do want that in there. So like, that's the cool thing. And so like this. Anomaly threshold. Anomaly detection record. Contention event. Conversion record. Conversion strategy. Cross feature usage. Lock contention info. You know, it just keeps going. And as you like, so like it continues on. Regression indicator, performance regression, like resource utilization. And so all of these statistics, all these little structs, see, struct, all of these structs are different features of my program, and I'm showing it to you. Snapshot analysis, another one. And you'll notice this little yellow line. That just means the function hasn't been defined yet. As you see, it's just a declaration. And it actually warns me about that. As you'll see, there's actually 24 warnings. And so it's a big giant mess. Basically, there's this warning. Let me show you. See, function definition for summary not found. Function definition for trend to strength not found. That's what that means. It means I haven't defined it yet. But that's okay because I'm still going through it. So then we got a snapshot comparison result, which has the basic information, you know, like snapshot A, snapshot B, performance deltas, CPU metric deltas, comparison outcomes, field by field comparison, and analysis. You are annoying. Why are you doing that? Go away. And then it goes on to a snapshot validation report. And to understand what I mean by snapshot, well, there's the state snapshot, and I'll show that in a little while. It's a couple files down. And this is the stuff that leads up to the state snapshot, if that helps. So this is a snapshot validation report. It has validation results, field validation, data quality metrics, validation issues, and then a bunch of functions that accesses those fields, and a summary function that prints everything out, and a reset. And then we go on to thread ownership info. Then we have tracking information for that, and a bunch of mutable informations that I still don't understand atomic, but I do understand. What I do understand about atomic is it makes it thread safe. That's all I know. I'm still learning, so you're learning with me on that one. And then we've got another one down here called, and see, this is what I mean. Look at this. This is AI generated. Okay, this is something that AI helped me create. Okay, why would you nest a struct within a struct? Look at this. Struct thread ownership info. Thread transfer records. I feel like thread transfer should be outside because it could be used everywhere. So let's do that right now. So where should I move that? Well, timestamp is later on. So let's go ahead and change this because I can't use timestamp here. This is to prove that I can program without AI. Haha! It was trying to help me, and I knew that already. So I've now transferred that to a chrono system clock time point instead of a timestamp, because timestamp is defined after threads transfer, and if it's something is defined after, you can't use it. So in order to use it in thread transfer, I'd have to move the entire timestamp struct above thread transfer, and I don't feel like doing that because it would break a lot of things, and I don't want to do that. So it's going to get converted. I had to convert that. So thread transfer, where should we move that? Where should we move that? Thread transfer. You know what I think I'm going to do? I'm going to go ahead and do this. I'm going to go ahead and cut. And we're going to go up, all the way up, all the way up, all the way. And we're going to take a look. Actually, we're going to drop it right here. Threshold and detection. Yeah, that's where it needs to go. And this is programming, right? So this is, you know, when you think, oh man, programming must be boring. No, it's not. Because this is where I get to explore my creativity, and I get to develop and build things in the way that I see fit. And I like it. I do. I thoroughly enjoy it. So we're going to go ahead and copy it there. So now that thread transfer has been moved out, we're going to have to get back to that struct we were working on. Close measure. We already looked at that. Statistics hub. Close that. Yeah, no, that has no double, nothing in it. Anomaly detection record, contention event, conversion record, conversion strategy. Oh, geez, Louise. Performance regression, resource utilization. And if anyone's wondering what that sound is, I'm a vapor. I quit smoking 6 years ago. I just have to quit the vaping part. So that's that sound, and I apologize. Oh, it looks like I got everything. See, now it's moved out. It's much cleaner. See, isn't that much cleaner? And now I can use that anywhere, right? Because it's here now. Anywhere in the, well, anywhere beyond that, I can use it. Like if I wanted to, I could just simply do this. In data quality score, yeah, we're going to add that. We're going to add that right there because see, now that I've removed that, look what I've just done. I've opened my program up to more possibilities. So now instead of thread transfer being literally stuck to only one struct, it's now usable everywhere, as I've just done. And this is programming. This is what programming constitutes. So let's continue. So we got thread transfer moved out, data quality score, okay. And I would probably do that for all of these, but I want to keep this video short. So thread transfer ownership info. Oh, that's a duplicate. That's a duplicate. And then we get into further advanced additional statistics structures for analysis. Cluster analysis, which has health and recovery metrics per cluster, anomaly metrics per cluster, duration metrics per cluster, outlier detection, stability, cohesion, separation, and risk, additional relevant statistics. So, I mean, and this actually, look at this, snapshot analysis. Snapshot analysis. Snapshot analysis. See what I mean? And that's what's the beauty of programming is then you can use components within each other. And that's what I'm doing here. But you don't want to overload it because then it just becomes ridiculous. But for now, it's what I've got. So like I said, we got cluster analysis with a summary. And that's it for now for the cluster analysis. The next on the list is the bootstrap result, which is real simple. It's used very, very rarely. And here's where the creepy part starts. Machine learning specific features. Uh-oh. Someone call Terminator. Because this is the machine learning prediction result. Uh-oh. It's got a predicted value. Uh-oh. And then feature vector metadata, which is another duplicate. I need to remove that. Timestamp observer. A timestamp observer. Timestamp state observer, I should say, rather. And then a timestamp observer, which observes the timestamp. Which brings us to the timestamp struct. And this is, so remember how I said did standard chrono? Well, instead of doing that now, we just have to use timestamp. Because timestamp has that already right here in the core time data. But because timestamp wasn't defined earlier, I had to use them the way they were done, like this. So after timestamp, which is quite long, might I add, update, refresh, set to now, reset, query methods. Is it recent? Is it stale? Is it expired? Is it the future? Is it past? Time to until now? Time since now? You know, set the health status, set operation status, set life cycle state. You know, bunch of different functionality when all it was before was a time point. But I've expanded that time point to a timestamp. And then we also have a callback timeout, callback execution context, which has a timestamp in it. Feature integration status, error context, a lifecycle transition record, a lifecycle tracking, which this is where, like, over the life of your program, this is going to be tracking. And notice we're almost to 10,000 lines. Feature interaction, alert. Ooh. See, another one. All right. Well, at least I'm here. All right. So this is what I mean by I'm trying to remove these structs out. So it has this struct has enough on its own plate that it doesn't need to be having this here. So we're going to go ahead and remove it. Cut. Okay, so now alert category has been moved over. Yes, I want to replace. I wish there was a way to disable that. And if anyone knows, leave it in the comments. I'm still trying to figure out Visual Studio. That's so annoying though. Okay, let's see. Alert action. I feel like alert action. Well, it's got a timestamp in it, so it can't be anything above timestamp. We'll go ahead and put it here. All right. I guess I gotta figure out where I'm gonna put escalation rule and suppression rule. Again, I can't put them above timestamp. Unless I want to change that, but I really don't want to. Because I don't want to have to, because timestamp has so many different functions, right? And I want to be able to use it in notification settings or the suppression rule. So, man, it's going to be a tough choice. Let's go ahead and close life cycle tracking, kind of see what everything is. And see, this is the struggle that I face. I've got to organize this in a proper way. So let's take these. After alert action. That makes sense. And the same goes with notification settings. And see, notification system. See, it created a notification system, but it made it like only for alert. That's not fair. What if I wanted notification settings for everything? Oh, there's a feature interaction. All right. I feel better. That feels a lot cleaner. Yeah, section 1's goodbye. Oh, oopsies. See, and that happens all the time too. That would have generated about 500 errors. That mistake right there. It's ridiculous. It's so sensitive. Yes. See, you're annoying. Why do I have to confirm every time? Ugh. Anyway, so that's alert. See, escalation rule. Ooh, an escalation system. So now that I've got that escalation system, I feel like that actually probably needs to go somewhere else. I don't know. And see, this is where I've got to kind of like, okay, what do I want where? You know, and AI can't help me there. AI is great for a lot of things, but that's not what he's. Uh, registered callback. You're another one. Can I put you outside of alert callback system? Oh, wait. I can't take that out. Because this very first member requires this. I can't. Crap. How can I do... Wait a minute. If I did this... Okay. And then if I did this... Okay, we'll go ahead and save the file. And it still doesn't work, but that's okay. It still doesn't work because there's so many errors. And now, see, look at that. I've now pulled that out, and it's much cleaner. This is why you can't rely completely on AI. If you want to build something yourself, you got to make it yourself. Which is another beautiful thing. Like, there is the power of a simple state change, and then a change record, and then a violation. Incomplete type. Ooh, it's getting crazy out there with the wind. And then it goes on to a violation, which has the alert callback system, and it just can. It gets more embedded, is basically what I'm doing. And there's a lot of different. Look at this, all these errors. Oof. It's obviously broken. But this is what I've been working on. It's maddening. Now I'm up to 12,000 lines. Jesus. I didn't even pay attention to that. Violation record. Validation. What? This declaration has no storage class or type identifier specifier? What are you talking about? Show potential fixes. What is going on? See, I caused problems. I caused problems. I shouldn't have done what I did. Oh, no, it's fixed. No, it's not fixed. Ooh. I haven't seen it so broken in a long time. uh, it's so broken. And it's so big. Like, oh my God. What have I built? And it just goes on. And like I said, there's a lot of problems with it. It's currently 355 errors. Save point. That's kind of cool. Forgot I built that. Oh, I think I went overboard. What do you think? Think I went a little too crazy with this? Cross-reference report. I think that's the last one. Yep. Hey, expected a declaration. All right, let's find out what's going on here. Oh my God. I may switch over to a game. Like I've got tomorrow. I think I'm done programming for the day, honestly. Like I've got some major work to do. I've got 355 errors. I think this is a tomorrow problem. It's 5 o'clock.